Hi students, problem number 5 in connected bodies. 3 blocks of masses m1 equal to 1 kg, m2 equal to 1 by 3 kg and unknown mass m3 are connected to massless strings which pass over two pulleys P1 and P2. So this is P1 and this is a P2. What is the value of m3 so that it is at rest? So the third mass m3 is at rest. For that, what should be the value of m3 is the question. So when m3 is at rest, the other end of the string is carrying the pulley P2. So the pulley P2 should be at rest. Since m3 is at rest, the pulley P2 also must be at rest. Therefore, the acceleration of m3 must be equal to 0. Okay, m3 is in rest position. Now, the other pulley P2 over which a string is passing through carries two masses m1 and m2, where m1 is equal to 1 kg, which is heavier than m2 1 by 3 kg. Therefore, the mass m1 is accelerated in the downward direction and the mass m2 is accelerated in the upward direction. But the tension in this string will be the same on both ends. So if T is the tension over m1, then the tension over m2 also will be equal to T. This is because the tension is T over the two ends. The tension above the pulley P2 must be equal to T plus T, that is equal to 2T. Okay? And on the left arm of this string also the tension will be equal to 2T because this system is at rest. Now we have to find the value of m3. So for that, let us draw the free body diagram for the three masses m1, m2 and m3. So let us begin with the mass m1. So m1 into g. So this is m1 into g. Its weight is acting in the downward direction and the tension T is acting in the upward direction. But the acceleration of m1 is what? Downward. So the acceleration is downward. So for this, the equation of motion, if I write, means m1g minus T is equal to m1 into a. So m1g minus tension T must be equal to m1 into a. This is the equation. Okay. And the free body diagram for the mass m2. m2 is a smaller mass comparing to 1 kg. 1 by 3 is smaller. So it is accelerated upwards. So here a is upwards and this is the mass m2. And here is also the tension T is upward. The weight m2 into g is acting in the downward direction. Since the acceleration is upward, I will write the equation T minus m2g. Okay, so here T minus m2g is equal to m2 into a. So this is m2 into a. Okay, this is called as equation 1 and let us call this as equation 2. Now you look at the mass m3 whose acceleration is equal to 0. So here a equal to 0. But the tension in the string is 2T. So this is the tension 2T. And the weight is m3 into g. So this is m3 into g. So if you write an equation for this 2T minus m3g is equal to 0. Or 2T is equal to m3 into g, and this is equation 3. So first we have to analyze the system. What are all the masses and what are all the forces acting on each mass by drawing the free body diagram. And you have to derive 3 equations of motion. Okay children, now you look at equations 1 and 2. I am going to add. So adding 1 and 2 equations 1 and 2 I add. So this is m1g minus T. Okay, so m1 into g minus t plus t minus m2g plus t minus m2g. I have added the left hand sides. So this must be m1a plus m2a. So this is m1a plus m2 into a. Now this minus tension and plus tension, no, they get cancelled. So what is remaining is m1g minus m2g is equal to m1a plus m2 into a. So g is a common factor. I can take m1 minus m2 into g is equal to m1 plus m2 into a. Now what are the values of m1 and m2 are given? I am going to substitute here. So 1 minus 1 by 3. So this is 1 minus 1 by 3 into g is equal to 1 plus 1 by 3 into a. So this is 3 minus 1 by 3, 2 by 3. So this is a 2 by 3 into g is equal to 3 plus 1, 4. So 4 by 3 into a. So 3 and 3 get cancelled. 2 2s are 4. 2a is equal to g. Therefore a is equal to g by 2. So this is the acceleration of the masses m1 and m2. So first we are going to substitute the value of acceleration a in any one of the equations and get the expression for tension T. So tension T, let us take T minus m2g or T minus m2g is equal to m2a or T is equal to m2 into g plus a. So this is m2 into g plus a. So this is g plus, instead of a I can substitute what, g by 2. And the value of m2 is also known, is it not? m2 is equal to 1 by 3. So I will write here t is equal to 1 by 3 into g plus g by 2 is 3g by 2. Okay, so this is 3g by 2. So 3 and 3 get cancelled. Therefore the tension is equal to what, g by 2. So tension also is equal to what, g by 2. Now we have to find the value of what, m3 only, no? Find the value of m3 is asked. So for that let us take the third equation. So from the third equation, equation 3 implies m3 into g equal to 2t. So m3 into g is equal to 2t. So this is now equal to 2 multiplied by the tension T is equal to what, g by 2. So this is g by 2. So 2 and 2 get cancelled and m3g is equal to g. So g also get cancelled. Therefore m3 is equal to 1 kg. It's equal to 1. Therefore the unit is 1 kg. Okay. So systematically if you solve each and every step, then the answer will be found as 1 kg. I hope you must have understood well. Fine.